All right, guys, welcome back. Last time we talked about surface area and volume of prisms, and today is very similar, except our bases are identical. Well, all the bases in this shape are identical. We're going to be talking about the cylinder. And the cylinder, the bases, the top and the bottom will always be a circle. Okay, and the circle can change sizes with the radius, but it's not like you have a triangle and then a trapezoid and a pentagon, a hexagon, all those. It's always a circle of whatever size. Okay, so we're going to be here on pages 121 and 123, and we're going to set all of these up like we have been, with kind of some notes on the left and examples on the right. So the title of these pages will be surface area and volume, surface area, volume, and we're talking about the cylinder. Okay, so here on the left page, we kind of took some notes last time. So I'm going to draw two different types of cylinders. So we can kind of draw it like our last ones. We can have the circle kind of facing us, maybe like a pipe or something. And arch this here and kind of make that circle there. Okay, so you could have a cylinder like that, or more commonly, we draw a cylinder like so. Something like that. Now, it's very close. I mean, it is a prism. It's a circular prism. My bases are both circles. Okay, there's my base and there's my base. And we're actually going to use we can use the exact formula for a prism for cylinders. Okay, so if we look at surface area, okay, and I'm going to flip back here because we had 2 area of the base plus perimeter times height. Well, if I draw this as a net, okay, I have my 2 circles, and then the middle portion is just one long piece. Okay, this is known as the lateral surface area. Okay, this piece here in the middle, it's one large rectangle. So I have circles, and because all the bases are the same, we can actually use what we know about circles to help us there. And we know, we'll just kind of put it up here, that an area of a circle is pi r squared, the area. And I'm going to put perimeter of a circle, which we know as the circumference, is 2 pi r. And the reason why I label it perimeter is because if you remember in this formula here, we needed perimeter. So we're going to use this formula. So we're going to take 2 area of the base. Now the bases will always be a circle. So we know that the area will always be pi r squared every single time, plus the perimeter. Now, because it's a circle, the perimeter will always be the same equation, 2 pi r. That's a perimeter times the height of the object or the distance between your two bases. So again, the r here is your radius. Okay, and the radius would be right here, r, or the radius might be right here, r, or the radius could be right here, r. All of those are the radius. And the height is the distance between bases. So this is your height, this is your height, this is your height. All of those are height, considered height. Okay, and then the perimeter was this length right here. This was P. Okay, which was this portion right here. This is P, and this portion right here was capital B, if you look back at this formula here. Okay, and for volume, we can do the same thing. Okay, volume is area of the base times the height, or how many circles does it take to go this distance? How many circles here does it take? So we take area of the base, which is always a circle, so pi r squared, times our height, which is h. Okay, so really, no matter what, in order to do surface area or volume of a cylinder, you only need two things. You need the radius of how big these circles are, plus how far your bases are apart. Okay, we're going to go over to page 123, and we're going to do a couple of examples, 3 to be exact. So we'll split this page up. We will go ahead and I think I did them all in green. We'll go ahead and draw our examples here. Okay, so we've got this cylinder. There, it looks like they give us 6 inches there, and they give us this is 4. Okay, there's one that they give us, and then the second one here. They give us this, and they say from here to here is 4, and from here to here is 5 feet. Okay, so they kind of give us some weird measurements there. They give us a diagonal and the width of that circle. And then this one's a bit tricky to draw. I have a half circle there. We're going to draw this up here, and we'll draw this there as well. Maybe a little bit longer. And then this arcs up here, arcs down and dotted. Oop, dotted, dotted. Okay. This is 10, and this is 7. Okay, so we're gonna look at surface area and volume of each. And sometimes it's easiest to maybe have a little Post-it note here with the formulas right beside you. So if you want to post it for that, just let me know and I can get one for you. Okay, so for surface area, we need 2 pi r, which the radius in this case is 4, so 4 squared, plus 2 pi r, which again is 4, times your height, which is 6. Okay, and we can put all of this into a calculator. Okay, just, use a multiplication, use some parentheses, do all of that. Okay, so we have 4 squared, so 4 times 4 is 16. 16 times 2 is 32 pi, plus 4 times 6 is 24. 24 times 2 is 48 pi. And if you put that into a calculator, you're going to get about 251.33, and we have inches squared. Okay, let's go to 2 decimals on these problems. Now for volume here, I'll put this back up here. For volume, we have pi r squared h. So pi r squared, r is 6, so 6, nope, r is 4 squared times h, which is 6. So we have 4 times 4, which is 16. 16 times 6 is 96 pi, which is about, I'm looking at the answer here, 59 inches cubed. In 2 decimals. Again, I encourage you to use the pi button. If not, use 3.14159. Okay. Now, moving to this next one, okay, we don't really have the radius and we don't really have the height, but what we do have here is this right triangle. I think I forgot to label that as a right triangle, but we do have a right triangle in there with sides 4, 5. Now, if you remember, this triangle shows up quite a bit, which is your 3, 4, 5 special right triangle. So this is 3, and this radius is half of that. So 2. They actually gave me the diameter. I only need the radius. So the radius in that case is 2. So filling out our formula here, we have 2 pi times radius, which is 2 squared, plus 2 pi radius, which is 2 times the height, which we found to be 3. So the 5 actually doesn't go in our formula at all. Okay, so you have 2 squared is 4. 4 times 2 is 8. So you have 8 pi plus 2 times 3 is 6. 6 times 2 is 12. 12 pi. And you will get about 62.83 feet squared. Sometimes they ask you to leave pi in it. So you would just add these two together and say 20 pi. Okay, sometimes they do, sometimes they don't. For volume, we have pi r, which is 2. So 2 squared times height, which is 3. So you have 2 times 2, or 2 squared, which is 4. 4 times 3 is 12. So you get 12 pi, which is about 37.7. It must have been a 0 there, feet cubed. That is to the 3rd power on that one. Now, these are very easy as long as you have the formulas. So again, just make sure you're remembering those formulas. Now, this one is a bit tricky because it is exactly half of a normal cylinder. So we're going to find this whole cylinder, and then we're going to split it in half. So we're going to find the surface area and volume of the whole thing, and then just cut it in half. Okay. Now, with some of the surface area, you have to add in this little portion on the bottom. So it gets a little bit tricky. Okay, so we'll start with surface area. Okay, so this surface area here only finds the outside of the shape. So we're going to say 2 pi r. R is half of this, which is 5. So 2 pi 5 squared plus 2 pi 5 times 7. But we only want half of that. Okay. But then in the bottom, I have this new surface, which is just a rectangle. So I have to add to that 10 times 7 to get that surface area down there. So we found the whole cylinder, cut it in half, which gives me all the outside, but then I need that bottom portion right here. Okay, so let me grab a calculator maybe, and I can show you. Okay, so we'll put this in together here. So I have 2 pi 5 squared. I'm gonna go ahead and hit enter on that. Plus 2 pi times 5 times 7. There's that. I got to divide that by 2. Okay. So on this whole thing, I get about 188.50. So 188.50. 188.50 plus 10 times 7, which was 70. So plus 70, which is about 258.5 units squared. Okay, so that one was a little tricky because we had to remember to add that bottom piece in there. Okay, do not forget about adding this bottom section back to it. Okay, now with volume, it doesn't hurt us with the volume because we just need to know these half circles, how many can we fit? Okay, so to find the area of the half circle, or we just find the whole volume and divide it in half. So you get pi r, which is 5 squared, times the height, which is 7, divided by 2. Okay, so you got 5 times 5 is 25. 25 times 7 is 175 divided by 2. We'll just put all this into the calculator at once. So pi times 5 squared times 7, and then divide that by 2. So you get about 274.89, and that is units cubed. And I forgot to do that in blue. Forgot to switch. Okay. So once you start splitting shapes, things get added to it. So don't forget about that. That's why I kind of wanted to show you that one. Okay. So there is surface area and volume of cylinders, much like prisms. The only difference is your bases are circles. So we'll get some practice with this, and then we will move on to the next shape. If you have any questions, feel free to ask. As always, thanks for watching. I'll see you in the next one.